Okay, so let's talk about some other parts, other objects that are in our solar system or near or comprise part of our solar system, but are not planets. So here are some pictures of the far reaches of our solar system. So we look at the last planet, which is the orbit of Neptune out here. Neptune is about 30 times the distance from the sun that the Earth is. It's about 30 AU. And there's actually a lot of very small objects that orbit. These are illustrated here. Very small icy objects. We're far beyond the frost line, which is only at 5 AU. So it's extremely cold. The sun is very, very dim when you're out that far. And there's a region called the Kuiper Belt, where there's a lot of these small asteroids and comets that reside in this in the Kuiper Belt, which just circulate around and make these very, very long period orbits. In fact, the Halley's Comet spends part of its time all the way out in the Kuiper Belt before it comes in close to the sun. So it's a region where there's a lot of objects. The total amount of mass in the Kuiper Belt is quite small. It's much less than the mass of the Earth, but it's spread out in a region of asteroids and comets. And here, there's actually regions even further out, far beyond. So here again, we have our solar system in this little size here, and extending out to a region of about 50,000 AU is this presumed region of dispersed small objects, asteroids, called the Oort cloud. This is somewhat hypothesized. Things that far, which are not illuminated, producing light themselves, are extremely dim, but it's presumed that it's thought that there is this cloud of matter that extends far out to tens of thousands of AU, getting close to the distance actually to the nearest star. Okay, so let's talk a bit more about the Kuiper Belt. So here again you see the orbit of Neptune. Here's sort of a plot, a distribution of these very, very small objects which circulate at extremely large distances from the sun, so out beyond Neptune. In fact, Pluto orbits in most of its time is spent orbiting inside the Kuiper Belt. Pluto is classified as a Kuiper Belt object. So the Kuiper Belt extends from about 30 to about 50 AU from the sun. It has a lot of small asteroids, as we said, and there's the largest ones known. Actually, there's asteroid Eris, which is a little bit bigger than Pluto even. And you can see there's a number of other named asteroids that have been observed in the Kuiper Belt, and here's the scale and the size of the Earth, just to show the size. So it's where Pluto resides. It's extremely cold out there, and the model for how objects could have gotten out to the Kuiper Belt, things could have gotten so far out, part of it has to do with objects being flung around by Jupiter, which is the largest planet in our solar system. It has a lot of gravity, and objects that originally may have been near Jupiter may have been slingshotted out to these very, very large distances. And over time, it's theorized that early on in the formation of the solar system, Jupiter is actually closer to the sun, where there was more matter, and had flung a lot of material out of the solar system into the Kuiper Belt and into the Oort cloud. Okay, so we have the Kuiper Belt, which is beyond Neptune, comprised of frozen objects. A lot of comets are out there. It's extremely cold. There's another region which is very important, and that's, we mentioned earlier on, it's called the asteroid belt. Okay, the asteroid belt is comprised primarily of asteroids, which are rocky material, which are not typically icy objects. So let's look where that is. Here, the asteroid belt is illustrated by this distribution of small objects, and it's between Mars and Jupiter. Okay, so here you have the Earth here. Next orbit is Mars, so it's just beyond Mars. So it's quite close in. Unlike the Kuiper Belt, which is beyond the last planet, this one is sort of mixed in between Mars and Jupiter. And the frost line, just for reference, we talked about, is about 5 AU, which is close to the orbit of Jupiter. So this is within the frost line. So these objects are not going to be gaseous like the outer gaseous planets, which are out here, and the rocky planets. These are going to typically be rocky material, and the origin of the asteroid belt is thought that there were these objects either they came from the origin of the solar system, from the aggregating rocks that form planets, but essentially a planet could not form in this region because it was too close to Jupiter, and there's a lot of gravitational strength from Jupiter, which tends to disrupt orbits of things, and and it's prevented there being a planet forming here. But it's been hypothesized that a planet should have formed in the absence of Jupiter. A planet would have formed from all of this material coming together and form a planet somewhere in this region. But it didn't, and so we have the asteroid belt. And this is close in to us, and asteroids that come towards the Earth typically will originate from the asteroid belt. Let's take a look at some of the objects. Asteroid belts here. Here's just a list. You don't need to memorize all of these. I just want to show you a few of them. That the largest one is Ceres. Okay, so if here's the Earth, here's our moon, much smaller, and Ceres is even much, much smaller than that. This is the largest one, which has a diameter of about 950 kilometers, about 600 miles across. So it's fairly big. But the next one down, the next largest object in the asteroid belt is already almost half that size, and it shrinks down from that. There's a lot of very small objects, and they're all located in this region between 2 and 4 AU from the Sun, in the asteroid belt. In fact, Ceres was in fact the first discovered asteroid all the way back in 1801. So they've been known for a long, long time. It's quite amazing to be able to see them back then with the telescopes that they had. Okay, so here's a typical asteroid, which is only 10 by 12 by 11 kilometers. It's not even round. It's very small, which is Gaspra. It's a typical asteroid that comes from the asteroid belt. And one of them is, one of the larger asteroids is called Vesta. We saw on the previous slide, Vesta is actually the third largest asteroid. Vesta is interesting because a few years ago, NASA actually sent a mission out called the Dawn spacecraft. They sent a mission out to explore around Vesta and actually circle around. This is a picture from the spacecraft. And that mission, the Dawn mission, after visiting Vesta, is actually going on to the largest asteroid, Ceres, next year. So let's take a little video which has some cool pictures of what the asteroid Vesta looks like. Okay, so let's go back. Okay, so Vesta is
family, and also the ability for that to do is pivot through this decision.
all right. So let's go back to Vesta and uh, go back to describe. Okay, so we've talked a little bit about the different kinds of objects that are on their solar system. I've mentioned meteoroids. I've mentioned asteroids. We have planets. So it's important to classify and learn about the different terminology, although there is some overlap between the different terms. So the classification of solar system, the first thing we want to know is how do you classify a planet? There actually is a formal definition of what a planet is. Okay, and there's three things an object must have in order to be considered a planet. So a planet is an object that orbits the sun. It has enough mass so that it's essentially spherical. And you notice in some of the pictures of the asteroids, they were not spherical. We'll talk a little bit more about that in class, but it has to be spherical. And the third thing, which is the thing that tripped up on Pluto, is it must have enough gravitational attraction to clear its neighborhood of other orbiting debris. So what does that mean? Well, if an object is large enough, like the Earth, it has a lot of gravity in the early Earth's history, had enough gravity to pull everything in around it through its own gravity and over time sort of absorb all the material around it, and we have around us essentially no material. It's clear around us. Okay, there aren't orbiting debris and asteroids flying around us. It's a clear neighborhood. That's how it's defined, and that is not true in the case of Pluto, and that's what tripped up Pluto because it's in the Kuiper Belt, and there's a lot of other objects out there, and it's not big enough to actually be on its own and have a clean neighborhood. So that's the definition. So at the top of this diagram is planets. And that these satisfy these three criteria. The next one's down like Pluto and Ceres, which are dwarf planets. So that's when they satisfy the first two and don't have enough gravity to clear the neighborhood of other debris. And there's a sort of overlapping terminology also for dwarf planets, and they're actually asteroids also. Okay, and then as we go down in size, so these are the largest, we get down to the smallest here. As we go down in size, we have other things, some of these not so important, these trans-Neptunian objects, and these are sort of various terms that we talked about, things that are in the Oort cloud. But okay, but smaller than asteroids, you have things that are like comets, which are primarily icy material we saw would reside out in the Kuiper Belt, way beyond the frost line. And these can be asteroids also. Um, and at the smallest scale, typically this division between asteroids and meteoroids, which can be of the same material, rocky material, or icy comet material, uh, distinction is typically around 10 meters. If something is below about 10 meters or so, it can be defined as a meteoroid. So this is the smallest object. So you go from meteoroid to asteroid or comet, depending upon whether it's rocky or icy, and then up to dwarf planets, which are objects that are going to be spherical, but can be surrounded by other matter, and finally on the biggest scale onto planets. And we will talk about this when we get back to class.